So this is the Chapter 7 practice test video key / tutorial. So question 1 says, what is the simplified form of each expression? So remember, we don't want negative exponents. So we're going to take the -2 and its base, which is just the 2, and we're going to drop that underneath the fraction bar. So in this case, we've got -1 over 2 to the second power now. Then we'll go ahead and multiply it out the 2 squared, and we get -1 over 4, and that is our answer. So -1/4. Question 2, we've got 4 over 3x to the 4th, all raised to the 4th power. We're going to take the exponent, we're going to apply it to everything inside the parentheses. So when we simplify this, we end up with 4 to the 4th over 3 to the 4th and x to the 16th. So the last thing we need to do is kind of evaluate 4 to the 4th, which is 256. 3 to the 4th is 81. And then we've got x to the 16th power. And so this is our answer. Question 3, we've got a fraction, or in this case a quotient, inside the parentheses raised to a negative exponent power. So before we do anything else, we want to get rid of this negative exponent outside, so we flip the entire fraction over. So that means x to the -3rd is on top, x to the -2nd goes to the bottom, and x to the 4th as well. Now it's raised to the 4th power. Now we take our exponent, which is 4, and we apply it to every exponent inside. So now we've got x to the -12th power over x to the -8th times x to the 16th. On the bottom part of our fraction here, we've got like bases, so we're going to go ahead and add those two exponents. So right now this top is still just -12. The bottom is x to the 8th power. And so now, with division, we subtract the exponents. So that means we've got -12 minus 8, which gives us x to the -20th power. We don't want negative exponents, so our final answer becomes 1 over x to the 20th power. Question 4, it says, what is the expression written using each base only once? So what they're asking us to do here is, since we know all of our bases are 10, we're just adding our exponents. And so 5 plus -2 plus 3 is going to give us the answer 10 to the 6th power. So it's 10 to the 6th power. Question 5 says, does the table represent a linear or exponential function? So to determine this, we look at the change in our y values. Well, for the first, from 2 to 4, I can be adding 2 or multiplying by 2. But then from 4 to 8, it only makes sense that I'm multiplying by 2. So that's the pattern that sticks. So as I'm increasing my y values, I'm multiplying by 2 throughout. Since I'm multiplying by a constant of 2, this is exponential. Question 6, does the rule y equals 5 to the x power represent linear or exponential function? Well, remember, if your variable x is an exponent, that's going to be exponential. So this is an exponential as well. Question 7, suppose the population of a town is 4,600 people and is growing at 4% each year. Predict the population after 8 years. So this is exponential growth. So y equals a times 1 plus r to the t power. And I know that my initial value a is going to be 4,600. My rate in this case as a decimal is 0.04, and my time is 8 years. So now I'm going to plug all of that in, and I'm going to have y equals 4,600 times 1 plus 0.04 to the 8th power. When I put that in my calculator, I get that after 8 years, there's right around 6,295 people in the town. So 6,295 people. All right, question 11. We're asked to simplify, or we asked for the simplified form of each expression. Remember, we want no negative or zero exponents. So in the first question, for question 11, remember, anything to the 0 power automatically equals 1. So that one's easy. For question 12, we don't want negative exponents, so that means that this x value, or the x variable and its exponent, have to move. So our answer becomes 4 y to the 5th over x to the 3rd power. And then in 13, we've got 5 over x to the negative 3rd, y to the 7th. We don't want negative exponents, so this has to move. And we've got 5 x to the 3rd over y to the 7th power. Continuing with simplifying, we're looking at question 14. This is just multiplication, so that means we're going to multiply the coefficients first, so 2 times 5, and then we add the exponents of the like-based items. So negative 4 plus 12 is a positive 8. So our final answer becomes 10x to the 8th power. In 15, once again, the parentheses here don't have anything outside of them, so they don't actually play a role here. So you're just multiplying all of the coefficients. So 4 times 7 times 2 times negative 8. And then you're adding the like-based items. So 2 plus 1 gives us m to the 3rd. And then 3 plus 5 gives us n to the 8th. So when we multiply our coefficients, we should get negative 448 m to the 3rd, n to the 8th. And this is our answer. In question 16, we do have an exponent outside of the quantity here, so we have to apply this to the exponent and the coefficient or the other portion of the base as well. So the negative 2 is getting raised to the 3rd power, negative 3rd power. And the p is also getting raised to the negative 3rd power, but we're going to take 5 times negative 3, which gives us negative 15. Both of these are negative exponents, so we want to drop them underneath in order to get rid of the negative exponent. So I've got 1 over negative 2 to the 3rd, p to the 15th power. Well, negative 2 to the 3rd power is going to give us negative 8. So our final answer is 1 over negative 8 p to the 15th power. Question 17, we have two different quantities with exponents outside. So the 9 is going to get applied there and there. The 7 gets applied there and there. So to start off, we get 2 to the 9th. And then 7/3 times 9, well, that's just 21. And then we've got 5 to the 7th. And then we've got x to the 42nd. So 2 to the 9th is going to give us the coefficient 512. And we need to multiply that by our coefficient for 5 to the 7th, which is 78,125. And then we still just have m to the 21st, x to the 42nd. The last thing we do is we need to multiply those together, and we get a giant number, which is 40 million m to the 21st, x to the 42nd. With question 18, we're subtracting the exponents because we're doing division. So it's negative 6 minus 13, which gives us x to the negative 19th power. We don't want negative exponents, so we drop underneath, and we get 1 over x to the 19th power. In question 19, we're still dividing, so we'll end up subtracting the exponent values of like-based items. But for our coefficients, 16 and 8, we can go ahead and divide them like normal. So we've got 2. Then for the a's, there's only one a. It's a to the negative 3rd. And for the b's, we've got 7 minus a negative 3, which would be like adding the opposite, so we get b to the 10th. And then c, negative 2 minus 6 would give us c to the negative 8th. So in this case, we want to go ahead and simplify as best we can. Well, we don't want negative exponents. So the a to the negative 3rd and the c to the 8th have to move. So we've got 2b to the 10th over a to the 3rd, c to the 8th. And this becomes our final answer. In question 20, we want to go ahead and simplify this before we try to evaluate. So instead of x to the negative 3rd, y to the negative 2nd, we know that these need to move in order to make their exponents positive. So we've got y squared over x to the 3rd. Then we're going to plug in the values for x and y respectively. So that's negative 4 squared over 2 to the 3rd power, which in this case we've got 16 on the top and 8 on the bottom, which gives us a value of 2. In 21, Mr. Witzke's Jaguar XK was bought in 2012 for $82,000. It depreciates by 7% each year. How much will it be worth in 2035 when his daughter will be driving it? So we know our initial value, or A value, is $82,000. Your rate is going to be 0.075. And the time, well, it was bought in 2012, and it's going to be driven in 2035, so that's 23 years. And this is going to be exponential decay. So y equals a times 1 minus the rate to the t power. So that means we've got y equals 82,000 times 1 minus 0.075 to the 23rd power. Now we're going to go ahead and evaluate this, and we should get that after 23 years, the car is going to be worth $13,648.15. Question 22, we want to graph. We want to graph the equation in our graphing calculator, then look at the table to find our points. I'm going to use some different points. I'm going to go -3, -1, 0, 1, and 3. You can still use the -2 to 2 if you want. I feel like these values are going to give me a little better a little better picture of my curve as I go to graph this. So at -3, I get 1.7. -1, I get 2.5. 0, I get 3. 1, I get 3.6. And 3, I get 5.2. And so we'll plot these points. So -3, right around there. -1, right around there. Oh, right around there. There we go. And then 3. And then 1, we're at 3.6, so we're up a little higher. And at 3, we're at 5.2. All right, so it's not a great curve picture, but we should be able to figure this out. So remember, with an exponential function, it's going to start to increase, but it's going to be a smooth curve that's going to come close to the x-axis but never really cross it. So our graph looks something like that. All right, 23, we look at 3,200 in principal, earning a rate of 2.5% compounded monthly, so that means 12 times, after 8 years. So remember, compound interest, we take the principal times 1 plus the rate divided by the number of times it's compounded, raised to the number of times it's compounded times years. So that means we want to plug in this information in order to figure out what the compound interest will be, or the total will be, after 8 years. So we've got our principal is 3,200 times 1 plus the rate, which is 0.025, over 12 times, or raised to the 12 times 8 power. Well, keep in mind 12 times 8, if you want to get rid of this, is just 96. And so you can put this in your calculator, and it's going to tell you that after 8 years, you've got $3,907.68. All right, question 24. Mr. Brandfast has been losing his hair rapidly over the years. If he started with 100,000 hairs and is losing his hair at a rate of 13% each year, how many hairs are left after 10 years of going bald? So this is a exponential decay. So we're looking at y equals a times 1 minus the rate raised to the t power. We know that our initial value is 100,000. We know that our rate is going to be 0.13 or 13%, and our time is going to be 10. So we're going to plug all that in. So y equals 100,000 times 1 minus the rate raised to the 10 power. And when we plug all of this into our calculator, we get that he has right around 24,842 hairs remaining on his head.